Welcome to the Project Scola podcast, brought to you by the Philos-Sophia Initiative Foundation, breaking through the barrier of scientific belief. I'm your host, John Trevor Berger, along with co-host Brian Murphy. And once again, we're joined today by our friend in Brazil, Professor of Physics, Raphael De Paola. We're here to talk about the work of Professor Wolfgang Smith and his foundation, the Philos-Sophia Initiative. The Philos-Sophia Initiative aims to facilitate transformative impact upon our civilization through the recovery of the vertical aspect of cosmic reality based upon the philosophical and scientific discoveries of Wolfgang Smith. The initiative proposes a dynamic outreach to minds profoundly committed to truth, inviting them to an encounter with a comprehensive worldview that integrates the fundamental discoveries of physics into the perennial wisdom of mankind. Dr. Smith's latest book, Physics, A Science in Quest of an Ontology, is now available at philos-sophia.org. That's philos-sophia.org. And you'll find the link directly to the product page itself in the show notes below. The book is available in paperback for $19.95 and in hardcover for $35.95. It's also available in ebook form on Amazon, Barnes & Noble, and iBooks, and you can reach those through our product page. Also, if you haven't already, we invite you to watch our documentary film on the life and work of Dr. Smith, The End of Quantum Reality. Visit theendofquantumreality.com, where you can rent or buy on digital streaming, and you can also buy on DVD or Blu-ray. Again, that's theendofquantumreality.com. You might also be interested in the film's soundtrack, composed and performed by Richard Delano, and you can listen to that anywhere you get your music from. And we also have a hard disk CD available through the website. Once again, as always, we remind you that we offer annual membership subscriptions to the initiative for $45. That's about $3.75 per month. And that gives you a complimentary rental of The End of Quantum Reality, a link to download Rick Delano's hit theme song to the film, One Way Up, advance access to things like this podcast, new articles and other special features as they come, some occasional member exclusive content, and more as time goes by and we grow. And once again, you'll find a link in the notes included with this episode below. Now, getting back to our interview, part 3 of 3. Bear in mind, this is part 3 of episode 2. If you haven't yet seen or listened to parts 1 and 2, you're probably going to want to go back and do that before you begin this segment, and you'll find the links to those in the show notes, as always. So here we go, episode 2, part 3 of 3, with Professor Raphael De Paola. Enjoy.
In a really illuminating sentence by Professor Smith, it is not the atoms that give being to the instrument or to the corporeal object. It is the other way around. Right. It is the corporeal world which gives existence, atomic existence, only when it's measured in the starting point of the experiment and then at the end point of the experiment. In between, you have to describe, at least this is the what the theory says itself. You have to describe them as potentialities, as a wave function that mixes many different potencies for the end result.
And would you say that the big error of contemporary theoretical physics is the concretizing of there's sort of a backwards extrapolation of measurement outcomes that have been collected over the last century, and there's a model, so to speak, of a quantum or of atoms generally, and that they assume that this is telling us through their equations the way things are or ought to be, and that they're, in other words, they're behaving, that they're operating under the assumption that there is this literally quantum reality that's there, independent of I was going to say observation, but really independent. I mean, I'm really more inclined to say in the absence of experimentation.
Yeah, well, the way you said concretizing, I think that the word professors says is refined.
Yeah, reifying, right.
Refined.
Thingifying.
Right? Yeah. It may be, on the other hand, that the more, I wouldn't say correct, or more fit way to describe stars, for example, maybe is in terms of quantum particles. Maybe it is, but the star actualizes the form, the environment, the whole environment, plays back and actualizes the thing as a star. But it is possible that there, the best description is in terms of quantum particles. It is, and I think that Wolfgang Smith would not dispute that, although he would say that is the environment that actualizes the real thing. The concrete thing is the star. There is another example regarding the environment. Let us drop a cat here inside our room, a living cat. Okay, it will fall to the ground. Perfect. Let us do the same thing at the moon. Well, physics will describe it qualitatively in the same way. The difference is in the gravity, because supposedly the mass of the moon is less than the mass of the Earth, and etc. But what is the meaning of saying that what you dropped is a cat in that environment? It will live for 2 seconds and run out of air. It's not a cat anymore. The physicist will respond, well, that's not what I am talking about. I say, okay, but this is what I am talking about. As in the professor that I mentioned earlier that spoke about the lion, and I said, well, for that to be an objection to what I'm saying, you would have to bring in the lion, and not you explaining the things. I would have that the lion explain the things. And he said to me, oh, but that's not what I'm talking about. And I said, that's what I am talking about. Do you see the difference? You see, I'm talking about the real concrete world. The environment more or less actualizes different potentialities. And as St. Thomas Aquinas says recurrently, even in Summa Theologia, regarding matter, as matter is on the side of a potentiality, it has potentialities for being other things too. And it more or less fights the inherentness of form, because it itself is fighting for other forms that can actualize it. And it all depends somehow in the environment too. If we get a living being and put it into an oven of a metallurgical company, well, it's not a living being anymore. It will be completely burned out. What will come out of this? Well, then you divided the things, and matter and space too. They are extensive concepts that apply to those things. And the environment also So when people say, is the Earth the center of the universe, for example? Because nowadays we have astrophysics telling the cosmological principle, which is the subject of Rick Delano's The Principle film, which is amazing film. We understand things outside there with this assumption that space or matter or the universe does not have a special place to it. I say maybe you are looking to a part of reality that is describable in mathematical terms, but let us put in all other aspects of things that make them concrete. Concretion comes from the word grow with. Concretion, crescer, means to grow with. Things are there, connected there. In what other part of the universe, so far as we know, moreover, as modern science keeps telling us, we did not discover intelligent life, maybe yet, maybe never. There are many different events and behaviors and operations that we only observe on Earth. Birds and singing and dance and all things that Brian described of art, literature, and etc. Are they or are they not part of the real concrete world? So this is a part of the world that your theory is not considering. It is not a fault of reality. It is a fault of your method. And one of the things that Olavo stressed once and again was the dictatorship of method that makes us think the other way around. We invent a method that is suitable for some purposes, but maybe, and now we see, are completely unable to deal with other things. Another note I would like to make here, to stress here. Nowadays, we speak a lot about complexity, right? In the hope, the failed hope, I propose, of describing the big in terms of the small. A bunch of particles creates those, the things that we see. If you try to describe a cat, the process of sensation, perception, and etc., in terms of particles, well, you have a very complex, let us say, problem at hand. But you can describe those things in very simple terms that are not mathematical. That's what I've done here. That's what Aristotle has done 2,000 years ago. They are complex if you imagine them as being constituted by particles. So complexity, science of complexity, it depends on how you look at things.
Yes.
It is complex if you try to construct it from below, but they are very suitable concepts for them once you give up that idea, which is the concepts of classical philosophy.
And it's interesting what you say, this thing about methodology, when you were talking earlier about how I think in the context of biology, you were saying, despite the fact that they think in terms of bottom up, causation and existence, they nevertheless make appeals to form. They make appeals to ends, or in teleology. Well, let's say they make morphological and teleological appeals in order to make sense of things. Well, the irony here is that I think they would probably say that that is merely methodological.
Would you say, John, that's the it's not wrong to appeal to forms, but it's just misplaced. And this is where you brought up that word concreteness, and I think it comes from Alfred North Whitehead, doesn't it? The fallacy of
Misplaced
misplaced
concreteness,
concreteness.
right? That's
And in
the
essence, that's what they're doing when they look at a quantum particle or an atom, and they conceive of it as a thing, as a tiny object that we just can't see because our microscopes can't go that far. But I wanted to bring this quote up from Heisenberg, because he's talking about atomic. He says in the experiments about atomic events, we have to do with things and facts, with phenomena that are just as real as any phenomena of daily life. But the atoms, or the elementary particles themselves, are not as real. They form a world of potentialities or possibilities rather than one of things and facts. And so this is the fallacy of that misplaced concreteness in a sense, because they're trying to give concreteness to something that has no essence. It has no concreteness. And this leads to all of the enigmas in quantum theory trying to put concreteness on something that has no essence.
Well, who said it even better, which you quoted the last, in our pilot episode, was Erwin Schrödinger, when he said, I beg you to believe, or whatever, that there is
I've
no
got that right here.
there's no same. Yeah, read that.
He said, yeah, so this is from Erwin Schrödinger and from his book, Science and Humanism. By the way, the previous quote from Werner Heisenberg was from his 1958 book, Physics and Philosophy, which Raphael quoted from earlier. But so Erwin Schrödinger, he says, we have been compelled to dismiss the idea that such a particle is an individual entity which in principle retains its sameness forever. Quite to the contrary, we are now obliged to assert that the ultimate constituents of matter have no sameness at all. And I beg to emphasize this, and I beg you to believe it. It is not a question of our being able to assert the identity in some instances and not being able to do so in others. It is really beyond doubt that the question of sameness, of identity, really and truly has no meaning.
No. That consequence that he pulls out is completely non sequitur. But the premise is right, but the consequence that he draws is wrong. In the quantum world, it really doesn't have the notion of sameness or identity is ruled out.
Mm-hmm.
But that doesn't mean that individuality does not exist in the concrete world.
Well, I think that he was referring specifically to
a single particle.
To the quantum, yeah.
All right.
Yeah.
Mm.
And as I mentioned last time, Raphael, I don't know if you heard our first episode, but I said that I think Schrödinger was probably grinding his teeth in writing that, because he was telling us something there that he was not a fan of his own discovery, and he was saying that being just in brutal honesty, because he said if he had known there was going to be all this damn jumping and with the orbitals and whatnot, he wished he would have never even gotten involved with the whole project.
So, Raphael, what is going on in the double-slit experiment?
Well, that's a challenging question. Well, in terms of the concepts we were discussing, let me come back a little bit to my story with the concept of matter. As a teenager and as a youth, I used to say that matter is what we see and touch, what our senses witness of the world. But once you jump into the books or the sayings by materialistic philosophers, the first thing that they bring out of the equation is not even form or substantial form, but the testimony of the senses. They pull back all color and taste and sounds and etc. They say that these things do not pertain to the concrete world, to the material world. As we said here and John said, Democritus said that, Galileo said that, Descartes had said that. So that's a philosophical quandary for me. That was a philosophical quandary for me. And I fought a lot with that. And then I started reading Aristotle. And well, the real beings, let's not talk about quantum mechanics yet, no, nor electrons and quantum particles, etc. Real beings have a composition of matter and form. So they have form. But there are different kinds of form. The substantial form is the thing that we capture with our intellect. But there are other forms, sensible forms, like color, sound, and taste, and the sense of roughness, and etc. Temperature. What once mathematics was applied to physics, what are capable of being described by mathematics? Quantities. There is a parenthesis that I would make that we could deal with it another time, that there are many different kinds of quantities that modern physics appeals to. Mass, volume. The first one is volume, space it occupies, it spreads over space. Format, the shape of the thing. And weight, mass, electric charge, spin, temperature, entropy, and you name it. It's a whole zoo of quantitative concepts. Some of them are more amenable to sensible experience. Some of them are much more theoretical in the sense that you imagine. That you have to imagine and then impose in the world to see if they respond correctly to what our equations say. Well, St. Thomas Aquinas used to say that out of the 10 Aristotelian categories, Aristotle, when is trying to express himself in which ways we speak of being, the way things are, he classifies the way we use the word being in 10 categories. The first one is substance. And then quantity, quality. We've been using here quality much linked to substance and substantial form. But now comes the thing. So substance, quantity, quality, place, not space, but place, time, but it's not this mathematical time, situation, because a cat can be in the same place, but it can be laying down, it can be on foot, or etc. And relations and action and passion, different kinds of way we use the word being, right? So instead of a Parmenidean classification of being and not being, he said, we speak of being in different ways. Well, and regarding the division or the composition of physical things, material things, into matter and form, Aristotle said that the accident of quantity inheres more proximately to matter, is what circumscribes matter. And the concept of quality is more to the form, points more to the form of the real being. Well, once in physics, you disregard the nature of the object, as we said, it doesn't matter for Newtonian gravitation, Newtonian mechanics, if the thing is a cat, a rock, or etc. Once you disregard that, you are taking out of the equation of your conceptual scheme the substantial form. And as I began saying just now, you subtract also the qualitative aspect, which is more linked to form. So colors, sounds, and etc., we're not dealing with that in the equations. So you end up with an intermediary piece of the world which has no substance and no sensible qualities, sensible forms, by definition, right? And you try to describe the world like that. And then comes all the success of Newtonian mechanics and parts of it, or things or branches of science that can be accommodated in the same view, which are electromagnetism until a certain point, and thermodynamics. These sciences are from the 19th century, 150 ways after Newton. They can be, those branches can be accommodated into a Newtonian worldview or Newtonian mechanics. You can describe things. You can stretch the conceptual Newtonian mechanics to accommodate these different kinds of quantities: temperature, entropy, electric charge, and so on. But then comes the experiment of the atomic with the atom. And at that point, as the equation by Schrödinger, which has his name, Schrödinger equation, which is not the only equation, it is approximate equation, by the way, but all other equations that describe the quantum particles, corpuscles, with many lines to that, because they are not tiny balls. Well, on the one hand, they are invisible by two different reasons. The first of them is that you suppose they are too small to see. But the second reason is that mathematics cannot deal with sensible qualities. It begins with leaving aside substantial form and qualitative forms. The equations of quantum physics have a two-layer, in fact, the equations have one layer, which, because they are wave equations, and mathematically, a wave can be described as a sum of other waves. And when I explain this to students, I call their attention to the following everyday phenomena. You are seeing the image from the screen, right? So there is some kind of information, be it material or not, it's not the question. But crossing that ray of light, there are an infinite number or a huge amount of other rays, in such a way that if I turn my head here, I can see the other thing here. And this ray, or a similar ray, is crossing every time the ray that went out from the screen and reached my eyes, right? try to imagine this information as tiny balls. If they were amenable to Newtonian impacts, we would never see the world as the way we see, as a kind of organized pattern. Because the light coming from the screen would be the particles, if they are of some kind, would be crossing with other particles, and we will see a complete noise, complete chaotic world, right? How do you describe this kind of thing? In waves, not particles. And a wave can be described as a sum of many waves in such a way that if I put my eye some inches ahead, I receive other informations. They sum up, making an end result that has a memory of where they came from, right? That's what keeps them organized information. Mathematically, the wave is perfect to describe this, because a wave can be conceived as a sum, a mathematical sum of waves. It's a special kind of sum. It's not pure arithmetics, right? It's a sum of functions, but it can be described as many different waves interfering. And there is where the problem of superposition of waves comes from in quantum mechanics, because we are describing things in a wave manner, right? In an undulatory manner. Well, in the two-slit experiment, we have an instrument, a kind of electron cannon, right? We describe the thing that went out as an electron. It has a almost perfect description in mathematical terms. The problem is to understand what it is describing. But the instrument is a real concrete corporeal object that we friction, it's not burn, we heat it, we make distillations, we make many different operations, chemical operations, putting matter in contact to matter and producing parts of matter. And we canalize those things with electric fields and magnetic fields, making a kind of ray of electrons, for example. And at the beginning of the process, we have a corporeal object, which we can see. At the end of the process, we have a corporeal object. Otherwise, it would be nonsense to compare one theory with another one, because we compare at the end the goodness of theories if they describe well what we see. At the end, we always appeal to the sensible testimony. That's why that's how we discriminate between theories, right? At the end, we have to appeal to what we see or hear. In a Geiger counter, for example, we hear those stalids, or I don't know the word in English, those little noises. And John had a very good observation about this, John. That is by Wolfgang, right? That quantum physics is nature's way. Could you complete, please?
Quantum paradox is nature's way of repudiating a spurious philosophy.
That's wonderful. Well, the quantities that are describable by all the equation of mathematical physics. And nowadays, our physics is not a physics like we explained in the first part. Nowadays, we tend to call all that part of Aristotelian physics, we call it metaphysics or philosophy. No, it's physics, description of the world at large, just that. But nowadays we call physics, the word physics is in fact mathematical physics, the quantitative aspects of the real world.
You could make a distinction between modern physics and pre-modern physics. That's a convenient way of...
Yeah. Now, the only way to describe between the two ends of the experiment, the starting off and the final end, is through a wave equation, using wave equations. There are relativistic wave equations, which Schrödinger is not. There are Dirac equations. There are equations for quantum fields. They are all wave equations. And because they are wave equations, this problem of describing many different solutions in one single mathematical object called the wave function, is all over the place in the quantum description. Because the description is in terms of waves, we are describing many different possible outcomes. That I think is already settled, right? But the thing in between can be described only in terms of wave equation, a superposition of possible outcomes with the corresponding probabilities, which is an immense and very beautiful achievement of human mind, because what is a probability is a quantification of possibilities. You have many different possibilities, but they may not be, and in general they are not equally probable. All right. Quantum mechanics describe the in-between with wave equations. The problem is that at the end, we have only one outcome. If we regulate the cannon, the electron cannon, with small enough intensity, we can send, and that happens with photons too, one at a time. So there is no question of it interfering with others in the same ray. No, it's just one at a time. I made a motion here that is that distracts us. It's not like a cannonball, right? It's not a billiard ball. At the end, although our description of the in-between mixes many possibilities, at the end, we end up with only one outcome, very localized. It's not a mathematical point, otherwise we could not see it. It leaves a spot in the screen. And that's why we say it's a particle. It started as a particle and ended as a chunk of matter, corpuscle. Yeah. This happening, this corporeal happening, using Wolfgang's terminology, makes part of the theory. This is called collapse of the wave function. The problem is that the link between the in-between and the end result is a probabilistic one, which is something that Schrödinger disliked a lot, and Einstein too. They fought with this, and every student of physics, once he understands the theory, fights against. But The question is, as you describe in matter, and matter has different potentialities for being different things. Like wood, for example, you have a piece of wood. What will you make out of it? Will you make a chair? Will you make a table or any other object made of wood? It is not in the wood, this capacity of being a chair. You have to appeal to something else that will actualize this or that form. As you're describing just localized potentialities, the in-between, the true object of the quantum equations are a matrix of potentialities. Because you're describing matter. Matter is in itself a potency for showing up in different kinds. But you're describing very simple things. You're not describing a chair, you're not describing a table, you're describing localization, spatial localization of what you fired out in the first place. So that's the intermediary of the experiment is what Wolfgang calls the physical world. And the bridge between the physical world and the corporeal, sensible outcome in the theory is made by this collapse, which is just probability. You cannot I'm missing the word here, see in advance. You cannot see in advance, predict, thank you. You cannot predict the actual behavior it will have. In fact, you can make this supposition. It is incredible what is behind Bell's theorem. We can make up this supposition. Let us suppose that the thing is actually just a chunk of matter that just because we chose not to observe, we did not observe. But let us suppose it was all along a localized particle. If you feed this supposition into the equations, the predictions you have are different from the predictions of quantum mechanics, of normal quantum mechanics. And you go to the experiment and you see that in a very large number of happenings, of experiments, you see that this interpretation is wrong. It does not predict the correct results. That's what's behind all this question of the Bell's inequalities, Bell's theorems, that were very much perfected during the last 60 years. And the more you try to impose in the in-between to the quantum object a localized reality, the more you perceive that this supposition is forbidden in the theory. It does not account for the correct results. So, a loose way of speaking is that we are appealing to math. Math deals with quantity. Quantity is on the side of matter, and matter is potency for being observed. So that's how I understand Wolfgang's solution. There's not a surprise that you find that mixing up of potentialities. Once you understand, you are studying the behavior of something that is more down to matter, to homogeneous matter, than to the world of forms or to the world of substantial beings. And the mathematical object itself, which is probability, is a mixture of happenings with thought, with human thought. It is the perfect instance of a mixture of behavior of real things with human imagination. And the Thomist philosophers call this beings of reason. So to the question, is the wave function a being of reason or a real being? Once I asked this to Wolfgang, and he said it is both of them, because it has both sides, as it should. I don't know if this is very satisfactory, but I think we are dealing with things that is another note of the concept of matter. It doesn't have much intelligibility, because the intelligibility of the world does not come from below, it comes from above. So every time we get unsatisfied with explanations about more basic layers of material things, this is a sign that we are dealing with matter. So it does not come as a complete surprise that those explanations are not too much intelligible. I don't know if this is satisfactory.
John, you had I'll segue to you in a second. So the enigma exists so long as we conceive of what's being fired as a tiny little object. And we have to understand that in between, let's say the instrument doing the firing and the endpoint is pure potency, no essence, no qualities, only possibility. And it's the actual corporeal entities at either end that determine the outcome of that mathematical equation that give it being. What's going on in between is there's really nothing going on, is there? I mean, it's just pure potency. The action is only happening at the beginning and the end. Between is only potency.
I agree with that. It is. It's not pure potency, because once you delve into the concept of matter, Aristotle will explain that at the end, in this abstraction of forms, you would reach the concept of materia prima, prime matter, which has no intelligibility, and because of that has no real existence. But it is a kind of limit concept.
And so the error is in trying to localize, conceiving of it as something in time and space, traveling through time and space.
Yes.
That's the localization. And so this is where the mystery appears to us, because we keep trying to conceive of that, and it's not that. It's very, very difficult for the human mind to conceive of something that isn't there. But yet is realized. So John, you could, maybe I could, you might have had the best description. I think you got it from Rick Delano, which is that it's really a theory of instruments.
No, that was my idea. No, what I got from Rick was that what quantum physics is all about is the measurement of probabilities, which enables us to manipulate the behavior of matter. Raphael, does that sound correct?
Yes, I would agree with that. It is a theory of manipulation of matter.
Right. So one of the things that I kind of joke about, it's kind of a joke, but it seems to have a truth to it, is that because we are dealing with these corporeal instruments and these probabilities, well, for one thing, like I say that, what we call a quantum is really simply a probability in relation to a particular experimental result. Would you agree with that?
Perfectly, because as I was going to complete the answer, it's not pure potency, because this
Right.
potency is
Materia
governed
quantitatis signata, right?
at first,
Okay.
philosophically is this
Yeah.
one, and scientifically, as I would say, it is subjected, governed by the environment of the corporeal things that you put that, and you can feed the equations with those. You can and you have to feed equations for the quantum object regarding the initial firing of the object and the different outcomes that you allowed it to show up. So there are experiments that you fire something here, and the only two possibilities are, let me see, left and right. You fire something, you manipulate matter here, make many different kinds of weird things, and you canalize things in order that the outcome can only be either left or right. It doesn't have to be 50-50. You could incline a little bit your instrument in such that you can produce 30-70 probabilities. So the environment makes part of the equations.
Now, see what Brian was alluding to, something that I tend to entertain, and what I was saying is kind of half jokingly, but it just seems to me this way intuitively based on this understanding of quantum theory or the quantum theoretic and the corporeal measuring, the corporeal, and that where with physics, and quantum physics, it's about measurement. Without the instruments, there's no quantum anything. So it seems to me, this is how it seems to me, is that quantum theory is like a guiding set of rules, let's say, for lack of a better way of putting it, guiding us to say, okay, these are the kinds of machines that we need to make to effect measurement, and that because without the measuring instruments, which are machines, I think that's would be correct. Without the measuring instruments, we have no measurement of this, and that. So, in a nutshell, it seems to me that, in a sense, at least, quantum theory is really kind of a theory of measuring instruments.
I see that you wrote that in the email, right?
I've said that. I've said it in many places. I'll put it that. I could say that.
Well, I'll have to ponder a little bit about this.
I think the point is that it's just that the upshot of quantum physics is about measurement, and without the instruments, we can't do quantum physics. So, and if we don't know quantum theory, we can't make we wouldn't know what instruments to make. So that's why it's like, so the instruments are kind of dependent, or quantum physics is dependent upon the measuring instruments, and the theory is what I presume it's the theory which enabled people 100 years ago or whatever to know what instruments to make in order to effect quantum measurements and quantum experiments. And since the quantum itself is not, it is sub-existential, as Wolfgang puts it, what quantum theory is ultimately about is the measuring instruments and the theory and that the equations and all of that are, like you said, what happened in this you could say a mathematical plane or stratum or sphere, that when it comes to the practical matter of fact, at the end of the day, we're not talking about little balls, as he put it, but we're talking about measuring instruments which have produced these specific effects, which only these instruments can affect. In other words, you can't go out into your yard with a yardstick and do a quantum measurement. You have to have these specific kinds of machines.
John, I think what you're getting at is the quote, "We have examined the footprints in the stand and discovered that they're our own."
Yeah, Eddington
or
said,
the other one, that the math isn't there until we put it there.
Right. Eddington said,
so it's
yeah,
you're saying the measuring instruments creates the quantum physics rather than the other way around.
Yeah.
Although the main object of the equations are not the instruments, I agree that the end testimony, we cannot elude them. Because the object of which we are speaking are not the instruments, but so
fair enough. Yeah, I see what you're saying.
It's not a theory of instrumentation.
Right. That's why I say it half jokingly, because I see what you're saying. Yeah, the equations aren't looking at the instruments; they're looking at what's between, so to speak.
I guess what I was getting at is there's no there until we put it there. We can, and in between that, there's only potency of what can be there until we put it there with a measuring instrument. Could we put it that way?
Yeah. Yeah, it has a strong the quantum theory has when we say potency, pure potency, no, it's not pure potency, not because of philosophical prime matter issue, not only because of that, but also because of the different possibilities, not only of happenings, but the different possibilities described by the equations. If you fire an electron or an energy compatible with only one electron, you cannot end up with an elephant flying. It's not that pure potency like that. You have many mathematical restrictions in terms of that are described in terms of energy and polarization, spin, electric charge, and so on. So there, it is almost like Newtonian mechanics, almost in this regard.
But would you say that those observables do not belong to the quantum system, but to it's only realized once it interacts with a measuring device?
Yes.
You can't know those. There is no charge until a measuring device measures a charge. Or there's potency for a charge.
Well, I think it's mainly the dynamic attributes, right? And then there are static attributes.
Okay. Well, because I wanted to go back, because you brought up a quantum particle, when you fire it, it doesn't become an elephant.
Right.
Thank goodness. that we know of. But I want to go back to that word. I wrote it down. You said that you use the word adapt. It's adapt, so it has to have an aptitude to be something, and it does not have an aptitude to become an elephant, obviously. So there's a potency to become something, and so it has a potency to become something that a measuring device or a corporeal object can interact with or take up or measure. So
Yeah.
that's
Mm.
yeah. But there is no, because it has no being unto itself, there aren't atoms flying around through the air, so to speak. You mentioned Thomas Aquinas. You've brought him up multiple times, and we've only touched on him. But I had another quote that I wanted to read from Wolfgang's book, Physics and Vertical Causation, which he provides a beautiful summary because it relates to this idea of celestial bodies that you mentioned, and it's about substantial form, and he says, Wolfgang writes, if it be the substantial form that founds a being, animate or inanimate, we now ask what it is that founds the substantial form itself, and that is what St. Thomas refers to as the act of being. And that is, as the master himself explains, the act of being is the most intimate element in anything and the most profound element in all things, because it is like a form in regard to all that is in the thing. The act of being, this is Wolfgang again, the act of being proves thus to be none other than the cosmogenetic act itself, viewed in relation to a specific being. And that act of being, moreover, bestows not only being, but also a power to act with an efficacy of its own. Mm-hmm. And then he goes on to relate to to celestial bodies. He writes, as Etienne Gilson observes magnificently, and this is Etienne Gilson, the universe, as represented by St. Thomas, is not a mass of inert bodies passively moved by a force which passes through them, but a collection of active beings, each enjoying an efficacy delegated to it by God, along with actual being. And this brings us to a crucial point, says Wolfgang again. On every level, that efficacy delegated by God entails a capacity on the part of created beings to achieve all manner of effects by way of vertical causation, beginning with the rudimentary examples pertaining to the inanimate realm previously cited in the context of quantum theory. So I think that was just a nice summation of relating substantial form to being and resolving the quantum reality problem.
And incidentally, you know, those what Etienne Gilson and Wolfgang say relate really closely to things that we've been discussing, because what Gilson describes is essentially, well, the first part that you read, what he's describing is essentially agere sequitur esse.
Yeah.
That and Wolfgang calls this substantial VC, or substantial vertical causation, where the act of a being being that which it is has exercises vertical causation upon its environment and other things insofar as is proper to its own nature, to its own substance, its own substantial form. Incidentally, I wanted to mention something about, you know, we're talking about celestial issues here for a moment. And, you know, one of the things that Wolfgang, excuse me, points out, you know, Raphael, you mentioned it might be best, it probably makes the most sense for us to talk about stars in terms of a quantum description, say. But, you know, one of the interesting things that Wolfgang discusses in a few different places in it throughout his writings is, you know, there's a beyond, we're terrestrial animals, well, creatures. And, he uses the example in one place of like the rocks brought back from the moon landing. Now, we are only going to be able to perceive, the scientist who is studying these rocks and its elements and whatnot is only going to perceive so much of that substance as is shared in common with terrestrial substance. There is, and this gets very metaphysical, because lunar substance as such is something that we're incapable of perceiving. Even more so, stellar substance is something, all we can know about a star is that which we can understand as earthly beings. What a star is in its nature, is really beyond our purview. Or at least it is certainly beyond the purview of the sciences. There are philosophical and theological, metaphysical accounts of what a star is, and what its essential nature.
Well, that's a very good point. Brian mentioned, let me come back to the notion of causation, right? There's a famous quote by Bertrand Russell complaining against not finding in mathematical differential equations any notion of cause. So therefore, like monarchy, we should dump it out of our descriptive concepts. Well, but of course there is not the notion of cause in mathematical equations, because cause is not a mathematical concept. There's not a mathematical correlate of the metaphysical concept of cause. By definition, a cause points to a hierarchy of being. By definition, if you don't understand that, you did not understand the notion of cause. And the notion of cause has to stop somewhere. The notion has to stop, because the real causation begins there. There's not there's a famous objection, stupid objections, against the notion of God being the prime cause of everything, and people respond to that. But what is the cause of God? But to one who responds that, I usually respond, well, if you ask for the cause of everything, you are receding infinitely. That is the famous counter objection against it. And that means you did not grasp the notion of what cause is. It has to stop somewhere.
And that relates directly to the question of the act of being, because and if we're speaking, in those Thomistic terms, that God is that whose nature is simply to be, so in which case this is how Aquinas keeps from going to infinite regress. He found that we rest finally not on an essence, but an act of being, as opposed to a being, or to put it more pithily, that whose essence is to exist. But that act of being permeates. Everything that exists must also have that act, but to a infinitesimally limited degree. Elsewise, we would be pantheists, all of us.
Yeah.
Well, without cause, there's no being, right? If you can't find a cause in a differential equation, okay, but where does the differential equation comes from? Who is conceiving of differential equations?
How does the differential equation operate in the world?
Yeah.
Where does its power come from?
The human intellect? or the human reason.
That's why I say that those people, without seeing that, always have or end up with an angelical vision of human being. They like to see us as outside of nature somehow.
I was just going to distinguish between angelism, the notion that man is pure intellect, with the notion that the intellect is beyond space and time. So if you look at Wolfgang's tripartition, which isn't really his, he always says, fundamentally, human nature is split into three levels: the bodily, corporeal, the psychic, the rational, where we do our calculations and where we think in time only, not space, and then the aveternal, where we, or rather the intellective, where we simply see what is, and that's beyond space and time, and intellect and reason operate within an interplay. So just in that respect, I would say that there's that sense in which we are almost aveternal creatures, but we're tripartite. We're an integral whole. We do have that level, but we also have this bodily level, and then we have a rational level where we think in time, I
was gonna say, John, you used the word split, and I cringed a little bit because we're not.
What did I say? What did I say? Split?
Well, you said that we described the tripartition as a split between three different aspects. No, it's fair enough. I just wanted to
distinction.
Three, because as you said, you corrected that we are integral wholes. That we have these three. We participate, you could say, in these three layers of being that proceeds out from the aveternal, or the intellective, the rational, corpus, anima, psyche.
Corpus.
Spiritus. Corpus, anima, spiritus.
Sorry, it's in Greek we have soma, psyche, nous, and then in Latin it's corpus, anima, spiritus. Right. Or intellectus.
Well, I think this is a good place to bring this conversation to a close. Once again, we've had Raphael De Paola, professor of physics at the Pontifical Catholic University in Rio de Janeiro. We've talked about all things materiality, and this will be the conclusion of episode 2 of the Project Schola podcast. It'll be available to members first, before it'll be released to the public. We encourage everyone to go to the Philos-Sophia.org website to check us out. You can also find us on YouTube. John, did you have anything to add, or Raphael, before we closed?
Well, I would just add, also, since we're listing things, we'll have links for The End of Quantum Reality and Wolfgang's new book, Physics and Science in Quest of an Ontology, which we touched upon here, and we talked some about the end of quantum reality as well. So check that stuff out, and once again, also we'll have a link for membership to sign up to become a member, because if you do like these discussions and want to get them ASAP, become a member and you get a few weeks advance release, and hopefully and a few other perks.
It also helps to pay for more content like this.
Yes, that too.
Well, I thank you very much for the invitation. We are partners, and I enjoy very much those conversations, and God bless you all.
Thank you, Raphael.
World up now. Once we write it down, 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 down. One way up.